Hey guys, my name is Vivek Sharma. Today we can cover this interesting problem that's called trapping rainwater. So in this kind of the problem we have been given these bar diagram, and in this bar diagram the blue color contains the water, indicates the water, and black bar is containing like some solid you can consider it's a building or some other materialistic thing, right? But this blue thing is that we have to calculate. Each width is of 1 unit, so I mean this width really does not matter. The calculation will be based on the height, total height. So let's see, this is the number one height, and also I copied this thing here as well on the whiteboard. So let's understand from here, like if it is 1, so this is 1, and then this is 2. So if we see here, this height is 2 basically, and then this is 1, so 2 minus 1 is, so 1 plus this. If we calculate 2 minus 1, this blue section, and this section is, let me take another different color. So this section basically would be, so this is red, so this section will be 0 and then 2, so this is 2. Okay, and then plus this section is 2 minus 1, so 2 minus 1 plus, and this section would be 2 minus 1 again, right? So this will be basically 1 plus 1 plus 2 plus 1 plus 1, right? So 1 2 and 2 4 and 6, so 6 is our output. So if you if we are able to observe the pattern, that how I am calculating, basically what I am doing, I am just doing the maximum height and minus whatever my minimum height is there, right? So that's kind of the pattern. I can follow the same pattern as well to solve this problem. And another way is to think about this problem is, let's say, let me take the pencil, and let me erase this guy from here, this calculation. So what I mean to say, like if this diagram, if I let's consider a couple of cases. Okay, let's say I am having this building, right, and like this. Okay, so this is the thing, and then water is raining from the upside, right? Then what will happen, the water will be there, but it will be slipping from here, right? So there is no way that I can measure this water, right? So this is kind of the invalid case, right? So this will be the invalid case. Same way the vice versa, like the if the building is here and then it's less than, then also water will not be able to trap, it will be fouled from this boundary. So in that case also be invalid. So the key part is here, when I am just traversing through my all the height bars, I just need to make sure that I am having this next bar is just greater than the current bar, right? And another thing is I am just maintaining this max height as well, right? So max height, and then the max height again, then if I get the lesser height, right, then basically I can just calculate the same thing again, right? So I can just calculate, okay, this is my water that I can just trap, considering that I will have another maximum height as well, right? So if there is another maximum height, I will go forward and I will calculate this maximum height as a, I will just keep tracking of the maximum, that what are the my maximum height is there, so that next time I can just do the same iteration again as well, right? So here the key part is basically, whenever I am just doing this, I just need to make sure that my previous and the next both are having some building, so that I can just trap that water. And if there is no such case, then basically I cannot trap. So in this kind of situation, let's try to solve this problem. Let's try to brainstorm different ideas, right? And if in this kind of scenario, if we take 2 pointers and if we traverse from the both the side, and if we consider the same scenario, right, and then whenever we encounter the scenario, whenever we encounter the maximum height, greater height, then we just keep track of the maximum height. And whenever we keep track, like whenever we encountered, okay, this is the next minimum height, next lesser height than the current height, then we just collect this water. and how we will collect that water is the maximum minus this current var. So let's say this is 2 and this is 1, then this water calculation will be 2 minus 1 1, so this measurement will be 1 itself. Similarly, we will be keep doing from the both the sides, so from left side and from right side, and the result will be like total accumulation of the water, that will be the result. And in this calculation, if you observe, like we are not considering even this building, right, and even this bar, and in fact we don't need to consider because there is nothing here and there is nothing here itself, right? So when we will be doing left is less than right, we will be just going from the both the side and we will be accumulating our water, and then we will assume that we are even not considering this middle bar, right? That's the highest of all the among all the bars, right? So let's quickly try to create some of the placeholder, then we can come back again to the whiteboard and then we can just try to understand. So as discussed the approach, let's try to take couple of variables, let's say left and right, and let's say max left as well, because we discussed like we can just traverse through from the both the ends, right? And why we are taking max left and max right, so that if we will start from max left side, then it will be max left, and whenever we will start from the right side, we will just keep tracking the max right as well, right? And let's say this is our result. So let's do the same thing here. If while left is less than right, then what we are going to do, we will be just checking like as we discussed here, right? So if this guy, so whenever if we are traversing from the both the end, and if let me just try to undo a couple of things, and then if uh, when we are going through from the both the ends, and then we are checking like whichever is lesser, right? So if left is lesser, then we will be starting from our left pointer, right? And if right is lesser, then we will be starting from the right side. So that's how we will be just we will be just saving some of the time, running time cost. So we will be optimizing a little bit time complexity in this way. So in this way, basically, because we are having the both the running pointers based on the left and right. So we will be traversing either from the left side or from the right side, right? And we will be using the same approach whenever we just hit our this maximum thing. This will be our maximum, and whenever we get the lesser than the current height, then we will be calculating this water max minus current, and then again if we encounter the maximum, then this will be the new maximum. And similarly we will be doing the same thing from the right side as well, the same pattern, and then we will be just accumulating our result. So that's what we will be trying to do it here. So let's say if height left is less than height right, then what we are going to do it here, if we'll be checking like if max left is less than, let's say if height left, right, then what we are going to do, we will be just assigning this height left to our max left, right? And if this is not the case, then basically we are simply doing the max left minus height left. So that's what we are doing, that's it. And let's increase this pointer here, and the exact same thing we will be doing in the else part. Just need to copy paste the same code, and let's do this for the right part, but this will be right minus minus, or in fact right will be our height dot length minus 1, because this is the right pointer, right? So this will be the height dot length minus 1, and this is the array. So this length, whatever the length is there, that will be the right portion. So this is right and this is left. So left is 0th index initially. So that's what we are doing it here, and let's correct these names here. Max right, let's do the same thing, max right, okay, right, and this is also right, this is also right, and that's it. Once we are able to do that, then just go ahead and return whatever our result is there, right? So let's call it result here as well. So that's the, I mean, that's the approach. And so that's the pretty, I mean, if we are able to understand the requirement of the problem and we are able to understand how to solve, I mean, what's the intuition of this problem, then I think the code is straightforward. So let's try to quickly compile this and let's see if for the compilation error. So max right, it cannot find, okay, because this is capital. So let's see. Okay, so this is looks like giving the correct result. Time complexity we calculate, like it will still be linear, and the reason of linear is because we are just traversing to the both the side, but we are going through each and every var to calculate, right? So it will still be order of n, where n is the number of elements, and the space complexity here is pretty good because we are not taking any additional space, so this will be still the order of 1. And let's quickly try to see. So this is working as expected, so that's cool. So uh, the main intention of this problem, I would say, like this will be just first to understand that how we can trap the water, right? As I explained couple of edge cases, like if this is the only case, then this will not be working, and similarly this will not be working. So we just need to make sure that we are just keeping track of the max height every time whenever we encounter the greater height, and whenever we are just going lower height, then we are just accumulating the water by the same formula, right? So the formula is max left minus height left, and similarly for the right side, max right minus height right. So if we are able to understand this pattern, then I think it should be straightforward. But first step would be like just to consider all the edge cases and just to make sure that we understand the requirement correctly, and we just make sure that we are just doing it correctly on the both the sides, so that let's say this bar itself can be confusing if we are not too much clear. But in our algorithm, basically we are just completely, we are not even considering this bar, right? So that's how this algorithm is working. So take some time, just try to brainstorm, just try to understand the requirement, then code should be straightforward. Thanks a lot, have a good one, bye.